Our brain is built up of thousands of millions of small units called neurons whose main goal is to process information. The mechanism with which they work can be simplified as basically fire an action potential whenever they receive a strong input through their dendrites. In the absence of structured stimuli, neurons are supposed to fire according to the Poisson distribution. This means that if we record the number of fires at a given time, we find the following distribution, which basically tells us that the probability that it fired n times is bigger for a small n, and it drops as n becomes larger. Let's try to prove this. We want to know how many times a neuron spikes in a time window of size t. Suppose the neuron fires with a constant rate r, then the probability to have a spike is r times t. The probability to have at least n spikes must be the product of all these probabilities, as these are independent events. We are going to divide this by n factorial to account for all the different ways that these spikes can be reordered, resulting in the same value of n. Now, because we want exactly n spikes, we have to impose that there are at least n spikes but no more than n of them. Take an interval between spikes I and I plus 1 that happened at times t sub I and t sub I plus 1. Divide that interval in m small chunks of size delta t. The probability of not having a spike in that small chunk is 1 minus r delta t. Since there are m of them, the probability of not having a spike must be 1 minus r delta t to the m. Now take the limit as m goes to infinity to get a power of e. Hence, the probability of no spikes in any of the intervals t sub I plus 1 must be the following product. This means that the final probability is this one, the Poisson distribution.